Hello student, welcome to Praveen Patel College of Diploma, Engineering and Technology, our department Humanity and Science. Our subject Applied Mathematics, so myself again Mrs. Smita Shekhar Kamble. Application of derivative, it is our chapter name, chapter number 3. Application of derivative, it is detailed part of the derivative. We have to concern with the slope, and today's lecture obviously depend on very interesting topic, maxima and minima. From these words, we have to understand maximum and minimum values of function using graph. Yes, maximum and minimum. The point at which the function changes either from decreasing to increasing, increasing to decreasing are called turning points. That is important, show in diagram. Y is equal to f of x, it is lies in the first quadrant, it is increasing way or decreasing way, which is depend at the turning points, the value dy by dx equal to 0. Obviously, the slope is 0. What it defined? Definition, maximum, let y is equal to f of x is the continuous function in x. The function y f of x increases in the interval m comma n up to x is equal to a, and then decreases the point x is equal to a is called maximum point, and f of a, the value of the function at x is equal to a, is called maximum value. That means the second order derivative decreases, that means the value is maximum. In the neighborhood of x is equal to a, the value of f of a is greater than any other value of f of x. What is defined by minimum? Yes, the function y f of x decreases in the interval p comma q up to x is equal to b, and then increases, then the point x equal to b is called minimum point, and f of b, the value of the function at x equal to b is called minimum value. In the neighborhood of x is equal to b, the value f of b is the smaller than any other value of f of x. That the condition y is equal to f of x to be maximum at x is equal to a. Let us check using the example. Find the maximum and minimum values of 2x cube minus 15x square plus 36x plus 18. We have the equation, we have to take the derivative. Yes, derivative is equal to 0, it is called turning point. So, dx cube derivative, x cube derivative is 3x square, x square derivative 2x, x derivative 1, constant derivative is 0. Now we have 3 into 2, 6x square, 15 into 2, 30x plus 36 is the our dy by dx. Now we have to take again derivative of this function, that is 6 into 2, 2x, x derivative is 1, 36 is 0. Now d square y upon dx square is 12x minus 30. Now maximum and minimum condition check for dy by dx is equal to 0. So we have to put, be careful in equation number 2, 6x square minus 30x plus 36 equal to 0. Divide 6 to both sides, we have the simplification, x square minus 6, 5s are 30, 6 are 36, 6 1s are. That's why 1x square minus 5x plus 6 equal to 0. Factor of these quadratic equations are x minus 2 and x minus 3 equal to 0. We know that x minus 2 equal to 0, x equal to 2, x minus 3 equal to 0, x equal to 3. Now we have to check maximum and minimum condition using the second order derivative equation, that is equation number 3. Yes, let us start. When x equal to 2, d square y upon dx square, 12 into 2 minus 30, 24 minus 30 minus 6 less than 0, that is negative. Hence x is equal to 2 is maximum. When second order derivative is less than 0, then x equal to 2 is maximum. To find maximum value, put x equal to 2 in equation 1. So y is equal to 2x cube minus 15x square plus 36x plus 18 is the equation. We have to put instead of x the value x equal to 2. 2 cube is 8, 2 square is 4, 2 remain as the same, 18 remain as the same. 8 into 2, 16, 15 into 4, 60, 36 into 2, 72 and 18 remain as the same. Simplification we start, we derive 46 is there. So maximum value is 46. So our value is 2, 46. Now case number 2, when x is equal to 3. We have the second order derivative 12x minus 30. 3 we have to put in instead of x. So we have 36 minus 36 less than 0. That means it is positive. If it is positive, that means it is less than 0. Then x equal to 3 is minimum. That means x is equal, it is x less than 0? No, it is what I write here using, that is 6 greater than 0. That's why it is positive. Hence, we have x equal to 3 is the minimum point. We have to put x is equal to 3 in equation number 1. What is equation 1? 2x cube minus 15x square plus 36x plus 18. We have to put the x is there 3. 3 cube is 27, 3 square is 9, 3 remain as the same, 18. Simplification, 27 into 2, 54, 15 into 9, 135, 36 into 3, 108, 18 remain as the same. Simplification start, answer is 45, the minimum value is 45. So, at the point x is equal to 3 and y is equal to 45, the function is minimum. In this way, we have to calculate maximum and minimum point. Next example, find the maximum and minimum values of y is equal to x cube minus 18x square plus 96x. We have to consider it is y. Y is equal to x cube minus 18x square plus 96x. We have to differentiate with respect to x to both sides. That is dy by dx is equal to 3x square because x cube derivative is 3x square. X square derivative 2x, 18 into 2, 36. 96 remain as the same, x derivative is 1. Now we have to find again differentiate with respect to x, d square y upon dx square is equal to x square derivative is 2x, 36 into x derivative is 1, 6x minus 36. Now we have to consider dy by dx is equal to 0. That means 3x square minus 36x plus 96 is equal to 0. So we derive and divide 3 to both the sides. So we have 3 upon 3 is 3, 1, 36 upon 3, 12, 96 upon 3, 32 is equal to 0. 0 upon anything is 0. So we have x square minus 12x plus 32. Factor of this quadratic equation, x equal to 8 and x equal to 4. We have to put x equal to 8 in the second order derivative. That is 6x minus 36. 6 into 8 minus 36. 8 6 are how much? 48. 48 minus 36, 12. So 12 less than 0 or greater than 0? Yes, it is obviously 12 greater than 0. So we have y is minimum at x equal to 8. Now we have to put the, instead of x, 8 in the first equation, that is x cube minus 18x square plus 96x. That is the x cube, na? So we have to put 8 cube minus 18 into x square is 8 square and 96x means 8. Simplify, we have to derive 128. So our point x is equal to 8, 128 is minimum. Now we have to put x is equal to 4 instead of x. To d square y is equal to dx square, 6 into 4 minus 36 minus 12 less than 0. So y is maximum. We have to put the value of x is 4. So 4 cube minus 18 into 4 square plus 96 into 4, that is 160. So we have to derive the value of maximum point is 4, 160. In this way, we have to solve maximum and minimum condition for the x cube minus 18x square plus 96x. Find the maximum and minimum values of x minus 1 bracket square into x minus 2. It is not in a linear way. So we have to simplify the bracket expansion. We know that a minus b bracket square is what? Yes. Let us start with our formula. A minus b bracket square is what? A square minus 2ab plus b square. It is the formula. We have to put the value of a is x, b is 1. So x square minus 2x plus 1. X minus 2 remain as the same. X into x square, x cube. X into minus 2x, minus 2x square. X into 1, x. Minus 2 into x square minus 2x square. Minus 2 into minus 2x minus minus plus 4x. Minus 2x into minus 2 into 1, it is minus 2. Equating start, x cube remain as the same. I write here 2 minus 2x square minus 2x square minus 4x square plus 4x and x is 5x and minus 2 remain as the same. So we have to take the derivative of such function. I erase all these things. So derivative of x cube 3x square, derivative of x square 2x, derivative of x 1 and derivative of constant 0. So 3x square minus 4 2s are 8x and plus 5 is the derivative. We have to differentiate with respect to x. Now d square y by dx square, x square derivative 2x, x derivative 1, constant derivative 0. 2 into 3, 6x, 8 into 1, minus 8. So second order derivative we define. To find maximum minimum dy by dx equal to 0. So we have to find this equation factor. 3x square minus 8x plus 5 equal to 0. We derive 3x square minus 3x minus 5x plus 5 equal to 0. We have to take the 3x common, x minus 2 minus here minus 5 common, x minus 1 is equal to 0. That's why 3x minus 5 and x minus 1 are the factor. Be careful, we have to take here middle substitution method of the quadratic equation. Now we have the 3x minus 5 is equal to 0 and x minus 1 equal to 0. Therefore 3x is equal to 5, x equal to 5 upon 3, x equal to 1. We derive the value of x is equal to 5 upon 3, x equal to 1. Now we have to check the maximum and minimum condition by putting x is equal to 5 and x is equal to 3. So it is for the homework, that is we have to put and derive the values of this. Find the maximum and minimum values of y is equal to 2x cube minus 3x square minus 36 plus 10. We know that x cube derivative is x square, 2x square, x square derivative 2x and x derivative 1, 10 derivative 0. So 3 into 2 6x, 2 into 3 6x and 30 minus 30 x derivative is 1. So we have to take the derivative with respect to x, 6x square derivative 12x minus 6x derivative minus 6. So consider dy by dx equal to 0. That's we have to put this quadratic equation 0. We have x square minus x minus 6 equal to 0. Factor of this quadratic equation 3 2's are. So that's why x minus 2 and x plus 3 are the two equation. We have to put x equal to minus 2. We have in equation d square y dx square is 12x minus 6. So instead of x minus 2, 12 into minus 2 minus 24 minus 6 minus 30. So it is maximum at x equal to minus 2. Put x is equal to minus 2 in equation number 1. So 2x cube minus 3x square minus 36x plus 10. It is the equation. We have to put instead of x is minus 2. 2 into minus 2 cube is minus 8. Minus 2 square is plus 4. So we have to simplify. Final answer is 54. Add x equal to 3, d square y upon dx square, 12x minus 6. Instead of x we have to put 12. So 12 into 3, 36 minus 6, 30. It is greater than 0. Therefore, y is minimum at x equal to 3. Now we have to put the x is equal to 3 in equation number 1. Y is equal to 2, 3 cube minus 3 into 3 square minus 36 into 3 plus 10. 3 cube is obviously 27, 3 square is 9 and 3 remain as the same. Simplify, we derive minus 71. So in this way, x equal to minus 2 and y is equal to 54, the point is maximum, and x is equal to 3 and y is equal to minus 71, the point is minimum. Be careful about the sign. Discuss maximum and minimum of the function tan x minus 2x. Y is equal to tan x minus 2x. Differentiate with respect to x. Derivative of tan x sec square x. Derivative of minus 2x. X derivative is 1. Minus 2 remain as the same. Differentiate with respect to x again to find the second order derivative. Sec square x derivative is 2 sec x into derivative of sec x is sec x into tan x. So derivative of 2 is 0. we have dy by dx is equal to 0. That means sec x